Hello and welcome to my video 7.4, Triangles, Sides, and Angles. So if you take a look at this first one, it asks for angle A. Now that's pretty difficult. But I'm going to give you a little bit of a reminder about triangle rules and take a little general perspective on not just triangle but other shapes as well. So if you think about a triangle, all of the angles are going to add up to something. And if you remember from previous grades, you might remember that all the angles in a triangle add up to 180. Okay, so let's take the basic triangle like this, for example. We've got 90 here, and we've got 45, and we've got 45. And that one's nice and easy to remember. So 45 plus 45 is 90. 90 plus 90 is 180. So that's how I remember that it's 180. But every triangle actually will add up to 180. So with that in mind, we can find out the last remaining angle here. So we have 180 minus 75, which will give us 105, minus 50, which would give us 55. So now we have 55, whoops. Sorry about that. 55 here. All right, so we've got the angle 55 there. So that's helpful. It's good to know. But what's really important is if you look at this line going all the way across here, right? That is a straight line all parallel with one another. That line and that line are parallel. Okay? They're actually the same line. Same with this line and this line. They're parallel. Okay? Which is important because if you have two parallel lines, this one and this one, and you have another parallel line, you know the angles are going to be the same in all whatever different spots, right? So, with that in mind, this angle is the same as this angle. This angle is the same as this angle. So this is going to be 75. And assuming that this is also parallel with this, now we can start making some cool, helpful other angles. So we have 75 there, but if this is parallel, so we've got this line here is parallel with this one, right? And this one is parallel with this one. Well, the one that's in between is this 50, right? So the one that's in between has to be 50, which means that the other one has to be 55. Okay, so the point here is to notice, whoops. I don't know what happened to my triangle. The point here is to notice that actually, if the angles are the same, so red and green here, green here, where red and green meet is going to be where red and green meet on the other side, or where orange and green meet is where orange and green meet on the other side, and where red and orange meet is where red and orange are going to meet on the other side. So that's where it's really cool. It's where you have parallel lines, they're going to make the same angles. Okay. So we said that triangles have a total of 180. And that's going to be our main focus because we're going to see a lot of questions just like this one. But you also need to look at other shapes. If you look at other shapes like a square, we've got 90, we've got 90, we've got 90, and we've got 90. So all squares and rectangles, and actually any four-sided shape, will have 360. Okay? And this rule is sort of going to work as you go up, but it's going to be harder to remember what a pentagon is, right? So basically, up in grade 9, we only focus on these two. But I'm going to tell you that all 5-sided shapes have the same angle, and all 6-sided shapes have the same total angle, and that sort of thing. Okay? So, cool information to know. Okay, so let's take a look at another type of question we might see. Something like this. Find the length of side AB, side AB if the triangles are similar. So I most helpfully put, yoicks, I did it again. Most helpfully, I put this little like tick above all these letters. So you can see that C is C here, B is B here, A is A. So between A and B, we have this 21, right? Between B and C, we have 12 and we have 4. Okay, so now we have something to compare. 12, let's see, 12 divided by 4 equals, we need to have 3 over 1, right? Now let's see if it works the same for A to C, A to C, A to C. It's going to be 15 over 5 is also 3 over 1. So that means that we need to have 3 over 1 for A to B, but we have to have 21 here, and we have to have an unknown, maybe, let's write it like this, unknown AB side, right? So to do that, we have to do this sort of cross multiplication thing. So we're going to be left with, basically what we're trying to do is move the AB on top. So we move the AB on top. So 3AB equals 21. And then, let's use a different color so we can see it. So 3AB equals 21. And then you divide by 3 here, divide by 3 here. And we're going to get AB equals 21 divided by 3, which is 7. So AB is 7. If they're similar triangles. Okay. Awesome. Let's take a look at the last question here. Jackie is 1.5 meters tall. When her shadow is 2 meters long, the shadow of the school's flagpole is 20 meters long. How tall is the flagpole? This is the type of question where you read it and you go, oh no, I don't know how to do this. But you actually do. You just need to take some time to actually draw out the situation. So let's do that. So let's remember that we have a sun here, right? Beautiful sunny day, because that's how we get shadows, right? The sun. So we've got a sunny day. We've got a nice ground, even ground. We've got a flagpole. Here's gonna be my nice maple leaf here. See if I can draw my maple leaf. There you go. That's my nice Canadian flag. Patriotic. Okay, so we've got a flagpole. And we've got Jackie, who is a little girl at 1.5 meters tall. Not super tall, not super short either, but, you know, medium size. So we've got her, and we might want to label some stuff here. So she is 1.5 meters tall. We don't know how tall the flagpole is yet. And we know her shadow is going to be 2 meters long. So I don't know if I can draw a shadow here, but let's try at least. Alright, so there's a shadow. And the flagpole is also going to have a shadow. And the shadow for the flagpole is going to be very, very long. Actually, I guess you wouldn't have a maple leaf on the shadow. All you'd see is just dark. Okay, so that's my shadow, you know. Okay. And so the shadow for the flagpole, it tells us, is 20 meters long. Okay, so we might not realize yet, but because of these sun rays, let's see if I can get yellow, the sun rays coming down, that's what makes shadows, right? So we actually have a triangle here for the flagpole, and we have a triangle here for the height of our Jackie. And that's unknown. Okay, so I'm going to actually draw these out to the side so that we can keep track of them a little bit more clearly. But this is our unknown, so I'm going to call it X, H, question mark, whatever. And we have 20 meters. And we know this is going to be the 90 degrees because it's the ground. And 1.5 versus 2.0. Right? And if these are similar triangles, then we need to compare the ratio here. So 1.5 divided by 2 needs to equal x divided by 20. Well, these numbers are really easy to work with because all we have to do is get rid of the decimals to get 15 over 20. So multiply the whole side by 10 maybe. Let's get a red. So just to show how to get to there, is multiply by 10. So 15 over 20, x, 20. Okay, now we have 20 at the bottom of both sides, so we can cancel that out by multiplying the whole side by 20. And x is, so multiply the whole side by 20, both sides by 20. So now x is 15. So how tall is the flagpole? It is 15 meters. Alright, so I hope this video helps you with 7.4, triangles, angles, and all the fun stuff in there, similar triangles. Good luck!